Hello everyone, it's Milad here, and today we're going to talk about measures of variation. These are numerical values that are used to describe the spread, dispersion, or variation in a data set. If the data points within a data set are closely grouped together, measures of variation tend to take on small values, and if the data points within a data set are more spread out, measures of variation tend to take on larger and larger values. In this video, we will cover three different types of measures of variation. The first one is range. Range is the difference between the highest and lowest data points in a data set. It's simple, intuitive, and very easy to calculate. However, it has a big flaw. It is affected by extreme values. Let's take a look at an example. Suppose these dots represent data points placed on a number line. Notice that my two samples have very different ranges, even though majority of the data points are almost the same. The reason for the second sample to have almost twice as large of a range than the first one is one extreme value. To avoid this problem, statisticians got together and they developed different methods that can describe measures of variation with respect to the center of a data set. Variance and standard deviation are two good examples of such measurements. Let's take a look at variance. Variance is the average of the difference of each data point and the mean squared. There are two different symbols for variance. The first one is sigma squared, which represents variance of a population, and the second one is S squared, which represents variance of a sample. The two formulas are slightly different. The biggest difference between the two is the denominator of the two fractions. For sigma squared, we have capital N in the denominator, which represents size of a population. But for S squared, variance of a sample, the denominator is lowercase n minus 1. Lowercase n represents size of the sample, but the reason we subtract that by 1 is to have a more accurate value for variance of a sample. Now, right now, I'd like you to stop the video, take a look at these two formulas, and see if you can figure out why variance isn't the best thing to use when we're looking at variation in a data set. Did you figure it out? Yes? No? Maybe? I'll tell you now. You see, the reason variance is not used as often as it should, it's because that its unit does not match the unit of a data set. For example, if I'm looking at, say, a cubic meter of concrete, and if I'm looking at their weights, the unit for variance for the same set of data would be kilogram squared. It is very difficult to interpret variance when the units of the variance and the unit of the data point don't match. To come up with a solution for this problem, we have developed standard deviation. Standard deviation is literally the square root of the variance. We don't have a separate formula to calculate standard deviation. It is variance, and then we take the root of that. The unit of the variance matches the unit of the data points, and that makes it very easy to interpret. Now, before we look at an example, I'd like you to think about these two formulas and answer this question. Can variance or standard deviation ever be negative? Can it? No. By the way these two formulas are designed, they will always produce positive values. So next time in a test, when you calculate a variance on a standard deviation and you get a negative value, you should know that it's incorrect. Go back and check your work. Let's take a look at an example. Oh, this is an example. These data points represent the amount of time it takes for a special type of construction adhesive to dry. I have 6 data points here, and to determine the variation in this data, I will determine range, variance, and standard deviation. All right, let's just start with range. Remember that range was the difference between two extreme values in your set, or in other words, the difference between maximum and minimum data points. In my sample, the biggest value or the maximum value is 6.4 and the smallest value is 3.5. Difference of the two values is 2.9 hours. That's the range for my sample. Next, let's take a look at variance and standard deviation. But first, remember that variance and standard deviation determine dispersion in a data set with respect to its center or its mean. So we first need to figure out the mean for this data. Notice that the mean has symbol x bar, Mean from our previous video had two symbols, x bar and mu. X bar represents mean of a sample and mu represents mean of a population. Because my data represent a sample, I will use x bar to refer to the mean of my sample. All right, so to calculate the mean, all you have to do is to add all values and divide by the number of data points. So sum of all these values divided by 6 is going to give me 4.93 hours. That's the mean of my sample. Now that I have the mean, I can use this formula to calculate the variance for my data. All right, so the top part of my fraction is the difference between each data point and the center squared. All right, so let's look at the first data point. My value is 3.5. The center of the data is 4.93. I find the difference between these two values and I square them. That will give me 2.56. I will repeat the same process for the remaining of the data points, and then to get the top part of my fraction, I would have to add them all together. Once I add all of these values, it will give me 6.66. That's the top part of my fraction, and I have to divide it by n minus 1. Lowercase n represents size of my sample, and I have to subtract it by 1, and it's because I have a sample here, not a population. Also, notice the symbol for variance and symbol for a standard deviation. I'm using s squared for variance instead of sigma squared to emphasize that I'm dealing with a sample, and for a standard deviation, I'm using s instead of sigma to emphasize that the standard deviation would belong to a sample. All right, so 6.66, which is the sum of all differences squared, divided by 5, which is size of my sample minus 1, is going to give me 1.33 hours squared. And that's going to be the variance from my sample. Last step of this process is a standard deviation. If you recall from our previous video, I don't really have a direct formula to calculate a standard deviation. It is basically the square root of the variance. So s, the symbol for standard deviation, is equal to the square root of s squared, or the square root of 1.33, and the value here is going to be 1.15 hours. That's the standard deviation of my data set. Thank you for watching. See you next time.